Hi folks, this is DiffyQ Take Home 2. We're turning the tables a bit. Instead of me giving you a differential equation to solve, I'm asking you to find a differential equation where this is the general solution. So we have to sort of rethink our process, sort of undo our thinking process when we solve DiffyQs. Well, normally when we solve a DiffyQ, we find the complementary solution and then add to it the particular solution. As I look at the solution given to me, the complementary solution is the solution that has the parameters in it. I have 1, 2, 3, 4 linearly independent functions that make up the complementary solution. That means I'm looking for a fourth order differential equation. What's left over, that's going to be the particular solution. And the particular solution is going to help me determine the non-homogeneous part of the ODE. So let's think about this for a minute. E to the 2x, x e to the 2x. How would I get those as being part of my complementary solution? Well, remember I would get that polynomial in terms of the variable m. And the zeros of that polynomial correspond to what goes up here. So e to the 2x tells me that m equals 2 is a zero of the polynomial. And since I have x e to the 2x, that means it's been repeated. So 2 is a zero of multiplicity 2 of my polynomial. What does that mean? That means that m minus 2 squared has to be a factor of my polynomial. So this accounts for 2 orders. Now I look at what's left over here, the e to the minus x cosine 3x and e to the minus x sine 3x. What values of m correspond to these guys? Well, these come from complex numbers, -1 plus or minus 3i. That means that m minus each of those has to be a factor. So m minus -1 plus 3i has to be a factor, and m minus -1 minus 3i has to be a factor in accordance with the factor theorem. So we start to multiply this out. I'm going to get m squared minus 4m plus 4 for this, squaring this out. And when I multiply these together, I can take advantage of some special forms. And I'm going to get m squared plus 2m plus 10. And if you multiply all this out, using all the techniques you learned from algebra, you're going to get m to the 4th minus 2m cubed plus 6m squared minus 32m plus 40. And that corresponds to the differential equation, fourth derivative of y minus 2 times the third derivative of y plus 6 times the second derivative of y minus 32y prime plus 40y. So that's the left-hand side of the DiffyQ. Okay, so this is the left-hand side of the DiffyQ. If I set this DiffyQ equal to 0, this is going to be the general solution. Okay, so that's the complementary part. Well, I've got this particular part left over, which means it's non-homogeneous. So this is equal to some function f of x. And the question is, well, what's the f of x? I need to find the f of x that corresponds to this yp. Well, how do I get the f of x? Well, if you think about how we solve for yp, we make an assumption as to what yp looks like, and we stick it in and solve for constants. And how do we do that? We stick it in and then match it up with f of x. So the way we're going to find this is that our f of x is going to be the result of plugging in our yp to the differential equation. Now, if you stick around for the bonus material at the end of the semester for our seminar that's going to directly follow the class, we're going to talk about differential operators. And this will all make a lot more sense when we get to that. But we're actually sort of looking at or developing this idea here in these problems. So I take my yp, I'll make a little column here. My yp is x minus e to the minus x. I'm going to start taking derivatives of it. I'm going to take this and plug it into that diffie-q. So I'm going to get minus e to the minus x minus 2 times e to the minus x plus 6 times this minus 32 times this plus 40 times that. And so let's see what we get. I get minus e to the minus x minus 2 more, so it's minus 3, minus 9, minus 41. Oops, I got a 40 there. Excuse me. So I got to make a correction here. This is plus 40y, so I need to take 40 times that whole thing. So it should be 40x minus 40 e to the minus x. So my total on e to the minus x, minus 1, minus 3, minus 6, that gives me minus 9, minus 41, minus 81 e to the minus x. Now let's look at our total on the x's. There's 40 of those. And about the constants, there's some constants here. There's a minus 32. So this, folks, is the right-hand side of the differential equation. So my final answer is the fourth derivative of y minus 2 times the third derivative of y plus 6 times the second derivative of y minus 32y prime plus 40y equals that f of x, negative 81 e to the minus x plus 40x minus 32. And how can we check that? Plug that in and see that it works. And that'll do it for Take Home 2.